Hello viewers, welcome back to my channel. In this video lesson, we are going to look at logarithm, more especially the laws of logarithm. So to get the best out of this video lesson, do well to get your writing materials and also watch this video lesson till the end. Before we look at the various laws of indices, it is important we take a look at the meaning of the word logarithm. Now, in one of our previous video lessons, we looked at indices, and indices is synonymous to logarithm. That means that they have the same meaning. Now, indices, like we said, is the plural form of the word index, and index means power. So also logarithm also means power. Now let's take a look at this number in index form. Let's say we have b raised to a power p is equal to n. This is the base, this is the power, and this is the number. In logarithm, we are going to write this as log of n to the base, that's b, is equal to power. So logarithm means what is the power to which b must be raised to give us n, and that power is what? P. Let's say we have 10 raised to the power of 2 is equal to 100. In logarithm, I'm going to write this as log 100 to the base of 10 is equal to 2. So it simply means what is the power to which 10 must be raised to give us 100, and that power is 2. So in mathematics, there are several bases to which you can express logarithm. For example, I can have something like 2 raised to the power of 3 is equal to 8 in index form. In logarithm, it's going to be log 8 to the base of 2 is equal to 3. Remember, what is the power to which 2 must be raised to give us 8, and the power to which 2 must be raised to give us 8 is 3. So there are several bases to which logarithm can be expressed. For example, in this case, we have log 8 to the base of 2, and we have log 100 to the base of 10. There are several bases to which logarithm can be expressed, but the most common base used in calculation is base 10. So logarithm to the base of 10 is called the common logarithm. So whenever you are being told about the common logarithm, just know that they are referring to logarithm to the base of 10. Now, coming to the laws of indices, there are 5 fundamental laws of indices which you should know as a student. Now, let's come to the first law. Law 1 is also called the addition law. Now, we have log x to the base of a plus log y to the base of a. What can you see in this case? In this case, the base are similar, a and a. So when we have a similar base, just like in indices, what are we going to do? We are going to pick one, log to the base of a. Next, we are going to multiply the individual numbers. X times y will give us x, y. Now, in solving this particular question, the base are similar, base 2. What are we going to do? We are going to pick one of the bases. It's going to be log to the base of 2. Now we are going to multiply these individual numbers. 3 times 5 will give us 15. So therefore, log 3 to the base of 2 plus log 5 to the base of 2 is equal to log 15 to the base of 2. We can only use this law when the base are similar, but if they are different, we can no longer apply this law. Coming to the second law, which is called the subtraction law. In this case, where we have log x to the base of a minus log y to the base of a, if the base are similar, we are going to pick one, log a. In this case, we are going to divide this individual number, so it's going to be x divided by y. Now, coming to this question, we have log 35 to the base of 2 minus log 7 to the base of 2. The base in this case are similar, so we are going to take one. So I'm going to write out log to the base of 2. In this case, we are going to divide these individual numbers. 35 divided by 7 divided by 7, and 35 divided by 7 will give us 5. So therefore, log 35 to the base of 2 minus log 7 to the base of 2 is equal to log 5 to the base of 2. Now coming over to log 3. Log 3 is a very crucial law. Now in this case, we have log y raised to the power of m to the base of a. What is so special about this log? Now you have a number, the number is raised to a power. Now how are we going to do this? When you have a number raised to another power, you simply move that power to the front of the log. So when we take m to this other side, it will become m log. When we take it here, we are going to have it as m log y to the base of a. Now, using it to solve this question, we have log 2 raised to the power of 3 is equal to 10. Now, in this case, what can I do? I'll move this 3 to the front of the log. So, in writing this expression, we are going to have it as 3 log 2 to the base of 10. Now log 4. In log 4, when the base and the number are similar, it is equal to 1 because the base here is a. The base in this case is a raised to this power. Remember, logarithm means power. A raised to power 1 is equal to a. That's why a raised to the power of 1 is equal to a. So when the base and the number are similar, without solving, just know that the answer is 1 because 10 raised to power 1 will give us 10. So if I have, let's say, log 5 to the base of 5, log 5 to the base of 5, without solving, the answer is 1 because 5 raised to power 1 will also give us 5. In the last law, which is log 1 to the base of a, if you have log 1 to any base, it is equal to 0 because a, which is the base, raised to the power of 0, and you know in mathematics, anything raised to the power of 0 is equal to 1. So in this case, I have log 1 raised to the base of, rather, log 1 to the base of 5. Without solving, the answer is 0 because 5 raised to the power of 0 is equal to 1. So we have some questions on the board which require us to apply the various laws of logarithm which we have learned in the previous part of this video. Now coming to question 1. Question 1 reads, simplify log 9 to the base of 4 plus log 21 to the base of 4 minus log 7 to the base of 4. Now going back to log 1 and log 2, when the base are similar, we can simply pick one. We have base 4 here, base 4 and base 4. So what are we going to do? We are going to pick one of the base. So it's going to be log 4. Next, remember in addition, we are simply going to multiply the number. So it is going to be 9 times 21. 9 times 21. Now in the subtraction law, we are going to divide. Divided by the number here, which is 7. Now 9 times 21 is equal to 189. And 189 divided by 7 is equal to 27. So this is going to be log 27 to the base of 4 because 9 times 21 divided by 7 is equal to 27. Now you can write 27 in index form, and 27 is the same thing as 3 raised to the power of 3 because 3 raised to the power of 3 will give us 27. Remember, in log 3, we said when you have a number raised to the power, you can take that power to the front of the log. So our final answer in this case is going to be 3, when I bring it 3 to the front, log 3 to the base of 4. So this is the final answer. Because 27 is same thing as 3 to the power of 3. You can move this 3 to the front of the log and therefore write it as 3 log 3 to the base of 4. So question 2 reads, simplify 2 log 9 to the base of 7 minus log 81 to the base of 7. Now going back to our third law, in our third law we can take this number to become the power to which 9 is raised. So I can write this expression as log 9 raised to the power of 2 to the base of 7 minus log 81 to the base of 7. Now 9 square means 9 times 9, and 9 times 9 will give us 81. So therefore this is going to be log 81 to the base of 7 minus log 81 also to the base of 7. Going back to our subtraction law, since the base are similar, I'm going to pick one. So this is going to be log to the base of 7 The numbers, I'm going to divide them. So this is going to be 81 divided by 81. So 81 divided by 81 is equal to 1. So I'm going to write as log 1 to the base of 7. Now remember, when you have 1 to a certain base, that answer is equal to 0. Remember in our fourth or fifth law, we said if you have log 1 to a base a is equal to 0. So when your number is 1 to any base, it is equal to 0 because 7 raised to the power of 0 is equal to 1. So in our third question, we have it that if log 2 to the base of 5 is equal to 0.431 and log 3 to the base of 5 is equal to 0.682, we are told to find the value of log 6 to the base of 5 and also log 27 to the base of 5. So let's start with this question. Now log 6 to the base of 5 can be written as log 2 times 3 to the base of 5. Now, 2 times 3 will give us 6. Also, 1 times 6 will give us 6. But in this case, we don't have the values of log 1 to the base of 5 and log 1 or log 6 to the base of 5. What we have from this question is 2 and 3. So we can simply write 6 as 2 times 3. Now, going back to the addition law, we can write this expression as log 2 to base 5 plus log 3 to base 5. What we are simply doing here is that we are reversing the addition law. Now, log 2 to the base of 5, we have the value here as 0.431 plus log 3 to the base of 5, the value is given here as 0.682. So when we add up, 1 plus 2 is 3, this is 11, this is 10 plus that 1, then carry the other one here. So definitely when you add this two, you are going to have 1.113. So in the second part of question 3, we have log 27 to the base of 5. So we have log 27 to the base of 5. Now we can express 27 in index form. Remember, 3 raised to the power of 3 is equal to 27. So I can write this expression as log 3 raised to the power of 3 to the base of 5. Remember, in one of the laws of logarithm, we can take this power to the front of the log. Definitely, we can write it as 3, when we take this 3 here, 3 log 3 to base 5. Now, log 3 to base 5, we have the value here as 0.682, so it becomes 3 times 0.682. So when we multiply this, we are going to have 2.046. So this is the final answer. So it all boils down to you understanding the various laws of logarithm. So our question 4 reads, express x as logarithm to base a. Now these questions are in index form. So we are going to express them first in logarithm form, then we are going to make x the subject of the formula. Now, coming back to question A of number 4. Now we have it that a raised to the power 2x is equal to b. In logarithm, I'm going to write it as log of the number, which is b, to the base a is equal to the power, which is 2x. So I can swap their position and have it as minus 2x is equal to minus log b to base a. Now minus will eliminate the minus sign, so I have it as 2x is equal to log b to the base of a. Now we are told to make x the subject of the formula. It simply means I'm going to divide both sides by 2. When I divide 2, we cancel 2. So therefore, x is equal to log b to base a over 2. So in the b part of this question, we have it that a raised to power 2 minus 3x is equal to y. So we can write this in logarithm form as log of the number y to the base a is equal to the power, which is 2 minus 3x. Remember, we have to make x the subject of the formula. So I'm going to take this 3x to the other side of the equation. I'm going to move this 3x to this other side. Then I'll take this entire logarithm to this other side. So when I take minus 3x to this side, I'm going to have that as 3x is equal to 2 Now if I take log y to base a to its other side, it's going to be minus log y to base a. Now remember, we have to make x the solid of the formula. That means I'm going to divide both sides by 3. So when I do that, 3 will cancel 3. So I now have it that x is equal to 2 minus log y to base a over 3. So therefore, when you make x solve the formula, the final answer becomes 2 minus log y to the base of a divided by 3. So viewers, I hope you learned something from this video lesson. Don't forget to like and share the video lesson. And if you have any question or suggestion, do it to drop them in the comment section of this video. And if you have subscribed to this channel, do it to click on the subscription icon and hit the notification bell so that you always get notified as soon as I upload new videos on this channel. Till you get to see my next video, do have a wonderful time.